Before moving to exercise 17.2, first let us know the formula related to the area of a trapezium. A trapezium is a quadrilateral in which one pair of opposite sides are parallel. So quadrilateral means any closed figure having four sides, and out of four sides, any one pair of opposite sides should be parallel. So here ABCD is a quadrilateral, and in this quadrilateral, the two sides AD and BC are parallel to each other. So let me represent this parallel side by an arrow, and the remaining two sides AB and DC are non-parallel sides. And the distance between the parallel sides AD and BC, which we call the height of the trapezium, and it's represented by h. And if height and the measure of the parallel sides is given, then the area of trapezium equals to half into sum of the length of parallel sides into height. So which is equals to half into the parallel sides are AD and BC. So AD plus BC into h. So this is the formula for the area of trapezium. So this formula is valid only if the height and the measure of the length of parallel sides is given. Now from exercise 17.2, let me solve question number 1, and the question is, find the area of the trapezium whose bases are 15 cm and 20 cm and altitude is 8 cm. So here is a diagram of a trapezium. This ABCD is a trapezium in which the parallel sides are AD and BC. And in the question it is given that the base are 15 cm and 20 cm. So the longer side is 20 cm and shorter side is 15 cm, and the altitude means height. So height is given 8 cm. Then the area of trapezium is half into sum of parallel sides into height, AD plus BC into h. So AD is here 15 cm, BC is 20 cm and h is 8 cm. So after replacing the value and after simplification, the area of trapezium is 140 cm square. Now let me solve question number 2, and the question is, find the area of a trapezium whose parallel sides are 77 cm and 60 cm and the other sides are 25 cm and 26 cm. So in this question the height of the trapezium is not given. So first we need to find the height of the trapezium, and then we find the area of a trapezium. So here I have drawn a trapezium ABCD, and the parallel sides which are AD and BC are 77 cm and 60 cm, and other non-parallel sides are 25 cm and 26 cm. Since the height is not given, so first we drop a perpendicular from point A and D, so which represents the height of the trapezium, and this point be E and this point be F. The distance between E and F is 60 cm, AD is 60 cm, EF is also 60 cm. Now altogether from B to C it is 77 cm. So remaining is 77 minus 60, which is 17 cm. That 17 cm has been divided into two parts. So here is one BE and another is FC. So if we take this BE x centimeter, then this FC will be 17 minus x centimeter. Now in the triangle ABE, we apply the Pythagoras theorem, which states that hypotenuse square equals to perpendicular square plus base square. So here our hypotenuse is AB, so AB square equals to our perpendicular is AE, so AE square plus our base is BE, so BE square. So hypotenuse square equals to perpendicular square plus base square. And the value for AB is 25 cm, the value for AE is h, and the value for BE is x. So after replacing the value, we have got 25 square equals to h square plus x square. Now we take this x square to the left hand side, then it will be minus. So that we can write h square equals to This 25 square is 25 into 25, which is 625, minus this x square. So let this be equation number 1. Similarly, we apply Pythagoras theorem on the triangle DFC. So in this triangle, hypotenuse is DC, perpendicular is DF, and base is FC. So using Pythagoras theorem, in triangle DFC, DC square equals to DF square plus FC square. The value for DC here is 26 centimeter. The value for DF is h, and the value for FC is 17 minus x. So after replacing the value, it is 26 square equals to h square plus 17 minus x whole square. Now the second term on the right hand side, that is 17 minus x whole square, we shift to the left hand side, and this sign will change to minus, and then it will be h square equals to 26 square is 26 into 26, which is 676, minus, and this 17 minus x whole square. So let this be equation number 2. Now we compare equation number 1 and 2. So in both the equation, the left hand side we have h square, here also h square. So we equate right hand side of equation number 1 and 2. Then it is 676 minus 17 minus x whole square. So which is the right hand side of equation number 2, equals to 625 minus x square, which is the right hand side of equation number 1. Now here we apply the formula, which is a minus b whole square. So a minus b whole square is a square plus b square minus 2ab. So this 676 minus, so our a square is 17 square, so 17 into 17 is 289, plus b square, so our b is x, so x square, then minus 2, a is 17 and b is x, and the right hand side remains same. And here we open the bracket, we multiply with this minus sign, then it will be 676 minus 289, minus into plus is minus x square, then minus into minus plus 2 into 17 is 34x equals to 625 minus x square. So here in the left hand side also there is a term minus x square, and in the right hand side also there is a term minus x square. So we cancel this term, and the remaining is 676 minus 289 will be 387, then plus this 34x equals to 625. Now we shift this 387 to the right hand side, then it will be 34x equals to 625 minus 387. Then after subtraction, 34x equals to 238, then x equals to 238 divided by 34, which is 7. So the value for x is 7. After getting the value for x, we put x equals to 7 in equation number 1. So our equation number 1 is h square equals to 625 minus x square. So there we replace x by 7. Then it will be 625 minus 7 square is 49. And after subtraction we will get 576. But in the left hand side there is h square. So we have to shift this square to the right hand side, then it will be square root. So h equals to square root 576. So after finding the square root of 576, h will be 24. So finding the square root you have already learned. Either you find by long division method or by prime factorization, you will get h equals to 24 only. Now we have got the value for height. After finding the value for height, now we can find the area of trapezium. So area of trapezium is given by the formula half into sum of parallel sides into height. So our AD is 60 centimeter, BC is 77 centimeter, and A is the height, which is 24 centimeter. So after replacing the value and after simplification, we have got the area of trapezium, which is 1644 centimeter square. So if the height is not given, then we have to follow this method. First we have to find the height, and then only we can find the area of trapezium.